Find any asymptotes of f of x equals x cubed minus 2 over the absolute value of x cubed plus 1. With any expression with the absolute value, we first need to rewrite it using the piecewise defined function. Keep in mind that the absolute value of a is a if a is positive or 0, negative a if a is negative. Thus the function f of x is x cubed minus 2 over x cubed plus 1 if x is positive. And if x is negative, then this function is x cubed minus 2 over, we replace the absolute value of x with minus x if x is negative. Now this is the same as x cubed minus 2 over x cubed plus 1, the first part, but the second part is x cubed minus 2 over negative x raised to the third power is negative x to the third power if x is negative. To find the horizontal asymptotes, we only need to check the end behavior of the graph. This means we take the limit at x go to either positive or negative infinity or both. At x greater than 0, we take the limit at x go to positive infinity of the function, which is now x cubed minus 2 over x cubed plus 1. There are two pieces, but we would use the first piece for any x value that is on the right hand side of 0, and as x go to infinity, that is on the right hand side of 0. And this limit, we know that it is 1. We employ the trick of finding the end behavior of a rational function again if the degree in the numerator is the same as the degree in the denominator. The limit is only the ratio of the coefficient of the leading terms, 1 over 1. At x go to negative infinity, we would use the second part, which is x cubed minus 2 over minus x cubed plus 1, and we know that this limit is negative 1 using the trick again. So we have two horizontal asymptotes. The horizontal asymptotes are equations, so we need to state the variable as well. Y equals 1 and y equals negative 1. What this means is that as x goes to infinity, the graph is approaching the horizontal line y equals 1. And at x approach negative infinity to the left, then the graph approaches the horizontal line y equals negative 1. To find the vertical asymptote, we first need to check where the function is undefined. The function using this limit is a rational function, and so we need to check where the denominator is 0. For x greater than 0, we see that the denominator x cubed plus 1 equals 0 when x cubed equals negative 1 or when x equals negative 1. Now on the surface, this might look okay, but this doesn't make sense. This expression only lives on the right hand side of 0. And so the fact that we come up with x equals negative 1, meaning that this denominator is only zeros for x on the left hand side of 0, which doesn't work. The restricted domain for the first part is that x has to be greater than 0. And so after we isolate x, we need to get a number in this interval. But x equals negative 1 is not in this interval. Now, for any positive number, x cubed is still positive. Positive plus 1 is still positive. Similarly, if we were to pick a number on the left-hand side of 0, we would use the second part. But if we have a negative number and we cubed it, we would end up with a negative number, but the negative sign in the front would make it positive, and so negative x cubed plus 1 will not be negative on the left-hand side of 0. But if we want to, we can still check it. Negative x cubed plus 1 equals 0 when x cubed equals 1, or when x equals 1. And again, for the second part, the restricted domain is on the left-hand side of 0. And so x equals 1 is not within the domain. And so there is no candidate for the vertical asymptote. We conclude that the function f has no vertical asymptote.